Hi, this is Alex from devstories.eu, High Performance Python Async, Episode 7 of 17. Handling geographic coordinates usually means messy string parsing. You write a query, get back a giant text string of numbers, and then burn CPU cycles tearing it apart just to find a latitude and longitude. Advanced Codecs with PostGIS inside asyncpg completely resolves this friction. When you pull custom types from PostgreSQL, you are dealing with codecs. A codec tells asyncpg how to translate a PostgreSQL data type into a Python object. There's often confusion here between the text format and the binary format. Text format is the default for many database tools. With PostGIS, a text query returns well-known text. This looks like the word point followed by the coordinates inside parentheses. It is human-readable, but reading it in code requires allocating strings, searching for parentheses, and casting characters to floating point numbers. Parsing text is slow, and it scales poorly when you are processing thousands of rows. You want the binary format. PostGIS uses a standard called well-known binary. When you configure your codec in asyncpg, you explicitly set the format argument to binary. The database skips the text generation and hands over raw bytes. Now you need a way to translate those bytes into something your Python application can actually use. This is where a Python library like Shapely comes in. Shapely handles complex geometry, and it already knows exactly how to read well-known binary. You tell asyncpg to use a custom type codec by calling the setTypeCodec method directly on your database connection. You specify the PostgreSQL type name, which is geometry, then you provide an encoder function and a decoder function. The decoder takes the raw byte string from PostgreSQL and passes it directly to Shapely's binary reader. Think about querying the location of the Empire State Building. Without a custom binary codec, your database returns a string. Your application parses it, builds a dictionary, and eventually creates a geometry object. With the binary codec in place, you execute a standard select statement. Asyncpg intercepts the binary data, runs your decoder function, and hands you a fully formed Shapely point object instantly. You can immediately access the x and y coordinates on the returned object. The process works in reverse for data going back into the database. Your encoder function prepares Python data to be sent to PostgreSQL. Shapely objects implement a standard called the geo interface. This is a common Python dictionary structure used for geometry. Your encoder takes any Python object that supports this interface, uses Shapely to serialize it as well-known binary, and sends those raw bytes back to the database. You never touch a text representation. If you are finding these deep dives useful, you can support the show by searching for devstories.eu on Patreon. Here's the key insight. By strictly using the binary format for custom type codecs, you eliminate the serialization bottleneck, allowing your database and your Python application to communicate at memory speed. Thanks for listening. Happy coding, everyone.